The museum was Hamilton's first municipal waterworks. We began to pump water here 150 years ago. And the story of bringing water to the city of Hamilton is full of the story of industry and innovation and the technology that surrounded the history of providing water to the city of Hamilton.
Prior to Hamilton having a municipal water system, Hamilton had three major problems. One was the spread of disease through water. We had 3 epidemics of cholera, with the worst one being in 1854, where 1 in every 40 people died from that disease. The second problem was fire. If your home or business caught on fire, that was basically the end of it. Insurance rates were incredibly high, so it was really unaffordable to most people. And then the third one was dust, and having a municipal water system would solve those problems.
The reason why the pump house is built in this particular configuration is because of the fact that this is a walking beam engine, and a walking beam engine doesn't have an integral frame like a modern engine does. It's more like an old-fashioned water mill, where the water mill parts hang from the water mill walls. Well, basically our beam engine hangs from the walls of the construction here.
This is something that I think everyone in Hamilton who works in distribution should see. They should be here. They should see how this all began, so they have an appreciation for what they're doing out there in the field.
So when you walk through the red doors 150 years ago, you were impressed by the size, the modernity, the beauty, and the power of this engine.
Mr. McFarland always had the windows open, much as we do nowadays. And as a result, we probably were somewhat less efficient than an English pump house, but our people tended to last longer.
What's really fascinating about this engine is that it's all locally made, from the brickwork, the stonework, the woodwork, to the metalwork of the engines themselves. John Gartor and his team of 200 fabricated and installed the engine within a 3-year period. The beam of the engine was the largest single casting that had ever been made in North America.
There's a good amount of lubrication, which is necessary, as you may imagine. Our guidebooks say they had to oil 105 lubricating spots every hour.
This building is absolutely world-class unique in its craftsmanship. You start looking around and you appreciate the craftsmanship that came from a bygone era.
People actually came in on their day off when they brought in, the pork or beef fat from their Sunday dinner, and you can render that down into a kind of grease that lubricates the engines better, and they shone everything up even though they weren't being paid to do it. They weren't being paid to come in. It was like the sports car syndrome. Everyone wanted to have the best looking locomotive in the roundhouse.
As Hamilton evolved from, village to town to the city that it is right now, it had to lay water in different directions, and in doing that, we laid water out up the escarpment because the city was developing in those areas. As far as topography, the topography is all over the place. Pipe has to fall the rolls of the hills. In those differences and in those changes comes a lot of challenges.
The water treatment process is basically a physical process. The object for that process is to bring in water from the lake and treat it so that it's clean, drinkable water. And that clean water is eventually pumped to the community, and the community sends it back as wastewater. Now, wastewater treatment is a totally different world. The object of wastewater treatment is to grow a bacterial culture, which we call a biomass. And that biomass is what does the treating. Okay, then we allow the biomass to settle out, and as it settles out into a tank, the cleaner water at the top is allowed to go out into the receiving waters. It's about 95 to 98% cleaner than when it came in.
Today's water systems are much more complicated than those of the past. They still rely on many of the same principles, including the passion and diligence of their operators.
As difficult as this has been a system to run, as difficult as the repairs have been at times, they prepare you to tell others of your experiences.
I appreciated going to work every day, And I think a lot of it was because of the fellows I worked with.
Anybody who lives in any kind of municipality where they're not on a cistern, they're on municipally supplied water, make the effort, get the tours. Most of them have tours. Find out where your water comes from. Find out where your wastewater goes.
Managing water and wastewater is a complex undertaking that requires expertise in many areas. The men and women of Hamilton's Water and Wastewater Division take their job very seriously. As one operator explained, there are a few jobs where you are responsible for the well-being of 500,000 people in one shift.
The City of Hamilton Environmental Laboratory became accredited through CALA, the Canadian Association of Laboratory Accreditation, back in 1996.
In 2000, a small town in Ontario became the centre of a lot of questions regarding the safety of drinking water and the training of operators in water and wastewater systems.
It was a big coup for the lab back after Walkerton happened, because all labs had to be accredited to analyze drinking water testing. So the City of Hamilton Council was very proud of us for already having taken that initiative at that time.
Since that time, the Ministry of the Environment and municipalities across Ontario have worked diligently to ensure their operators receive the best training available in both water and wastewater treatment.
So after Walkerton, and immediately after Walkerton, the whole of the water industry was basically put on the carpet to do things better and display that they had expertise. They were the guys who you would trust to take care of the system.
Yes, there's a group of guys that are controlling your water. Well, yeah, we are. We're also legally responsible for it, which means if something happens, we get hung out to dry.
Certification made sense. Finding out what operators could do made sense. In fact, I kind of like the ministry pointing to us and say, you know what, you guys do one very unique thing, and we're going to certify you. We're going to actually turn you into professionals at it. I don't know how anyone could not want that kind of exposure.
Well, the lab tests for a variety of things. We have an inorganic section that tests for nutrients, phosphorus. We do BODs, ammonia, like nitrogen, nitrate, nitrites, silica, a lot of different analytes in that lab.
What they've done now is they've changed it where you actually have to go through all the proper channels and go get your OITs, your operator in training, and then write your level 1s, your level 2s, your level 3s, and then your level 4s.
In the metals lab, we also run all trace metal analysis. So we have an ICP that runs a scan of over 26 elements at one time.
So a wastewater treatment plant separates liquids from solids. We clean the liquids as much as we can. We put the liquids back out into the harbor. The solids go in these big vats beside us here, and they rot for 10 days. And what ends up happening with those solids rotting, they create methane gas. We harvest the methane gas, which is in the large globe behind us, and we store that methane gas, and then we burn it in this huge engine here and generate electricity with it. We sell that electricity and we make a profit for the City of Hamilton.
The Hamilton Water and Wastewater Division is committed to promoting environmental responsibility and protecting our community's natural resources.
So we got permission to build a new laboratory, which was much needed because the old building had been around since the 60s, and they decided to design it as a LEEDS building, which is Leadership in Energy and Environmental Design. So it means that they looked at energy and efficiency right from the architecture, the drawings, right through building, monitoring all of the waste, to the finishing projects.
Right now this is called a secondary treatment plant, and we want to go to a third level of treatment called tertiary treatment or polishing. And what we're going to do is we're going to build probably the biggest membrane plant in the world here, and it's going to use a technology of a filter membrane that's basically going to clean all of the things that we couldn't get out of the water through settling, through biological treatment, and it'll be cleaner than the water we actually bring in to treat for drinking water.